Okay, so I will just go through that. Okay, wait a minute. Okay, yeah, everything is fine. You can see me and you can see the screen. Yes, everyone. Okay. Okay. Yeah, sorry for the interruption. Chelate. So what is chelate? An inorganic metal complex in which, yes, thank you, in which there is a close ring of atoms caused by attachment of ligand to a metal atom at 2 points. So what is the meaning of chelate? Is what there are more than 2 atoms present in a given ligand. Okay, और जो भी ligand होगा उसमें 2 atoms होंगे donating, और वो 2, अगर उस तरह से 2 ligand अगर हमारे कॉम्प्लेक्स में प्रेजेंट होंगी तो वहां पे क्या होता है, रिंग फॉर्मेशन जैसा स्ट्रक्चर तैयार होता है. कैसे होता है वो स्ट्रक्चर देखो, इस तरह से. मैंने यहाँ पे कॉपर सेकंड का कॉम्प्लेक्स लिया है, ये वाला. ठीक है, कॉपर को क्या कर रहे हैं, ये देखो, ये एक लिगैंड है इथिलीन डायमाइन का, और ये एक लिगैंड है इथिलीन डायमाइन का. दिस इज वन लिगैंड, ओके, विच इज हैविंग 2 डोनर एटम्स. और ये सेम लिगैंड मैंने यहाँ पे लिखा है, तो ये 2 हो गए ना, 2 लिगैंड्स प्रेजेंट है. ठीक है, और एक लिगैंड में bidentate species present. ठीक है, that is, this is a bidentate ligand and this is also bidentate ligand, and they are forming a ring like structure here, and that's why when it forms a ring like structure it is known as a chelate. Okay, it is known as a chelate, and these chelate are more stable as compared to the normal complexes. Okay, that is very, very important. Chelates are more stable, okay, than the formation of normal complexes. Okay, chelating complexes are more stable. Next, ambidentate ligand. What is the meaning of ambidentate ligand? So ligands which can link through 2 different atoms present in it are called ambidentate ligand. For example, NO2. You can see in NO2 nitrogen is also donating, oxygen is also donating, HCN minus. Here what is happening? Sulfur is also donating and nitrogen is also donating. So that's why when a ligand contains 2 different atoms which are donating, then that is known as what? Ambidentate ligand. हम इसको ambidentate नहीं बोलेंगे क्योंकि यहाँ पे नाइट्रोजन और नाइट्रोजन सेम एटम्स है ना. ठीक है, तो दिस इज bidentate ligand. See, the difference between these are different. Okay, so next, so you know that our coordination compounds are what? Coordination compounds are what? Okay, there are 2 types of compounds, double salts and coordination compounds. So carnallite, Mohr salt. So these are certain examples of double salt you should remember. Okay, ये remember करना है. और मैंने आपको बताया कि इथेन 1,2 डायमाइन एंड ऑक्सलेट, ये जो है वो क्या है? डाइडेंटेट, और यू कैन कॉल देम बाइडेंटेट लिगैंड्स. ओके, आपको मैंने बोला कि EDTA क्या है हमारा? हेक्साडेंटेट लिगैंड व्हिच कंटेन्स 2 नाइट्रोजन एंड 4 ऑक्सीजन डोनर एटम्स. Right? Is this correct? Then complex compounds with chelating ligands are more stable than the complex compounds containing unidentate ligands. मैंने आपको अभी कहा कि जो chelating ligands present होंगे उनसे जो हमारा compound form होगा that will be the more stable complex as compared to the unidentate ligand. Is that clear to everyone? Right? So these 2 are what? Ambidentate ligand. I have just told you. Then next is a homoleptic complex and heteroleptic complex. So what is the meaning of this? Homoleptic means only one kind of ligand is present in the given complex is known as homo. Homo means what? Same. So here NH3 is what? Only ligand present. There are 6, but that is the one type of ligand present in the given complex. Heteroleptic complex means what? There are more than one ligand present in a given complex. So यहाँ पे NH3 है and Cl2. That's why this is what? Heteroleptic. Right? Everyone, you are getting this? Next, naming of coordination compounds. So this is very, very important. One question is mostly asked on this concept. Okay, how you are going to name a given coordination compound. So the following rules are used for the coordination, naming the coordination compounds. The cation is always named. The cation is always named first. Okay, whatever is the cation present, you should name it first in both positively and negatively charged coordination entities. Okay, you should name it first, whether it is positive or negative coordination entities. The ligands are named in alphabetical order. जो भी ligand present होंगे उनको हम लोग alphabetical order में उनका नाम लिखेंगे. Name of the anionic ligand ends in O, and those of the neutral cationic ligands the same except aqua for H2O, amine for NH3, and carbonyl for CO, and nitrosyl for NO. While writing the formula of coordination entity, these are enclosed in bracket. जो भी हमारे ligands होंगे उनको हम लोग क्या करेंगे, ब्रैकेट में लिखेंगे. Okay, we are going to write them in a bracket. If there are more number of ligands present, then we are going to use the prefixes like mono, di, tri, जितने होंगे उतने. अभी हम लोगों ने लास्ट मॉलिक्यूल देखा, देखो यहाँ पे क्या है 6 है, तो हम इसको क्या कहेंगे हेक्सा. ठीक है, यहाँ पे क्या है 2 है, तो हम इसको बोलेंगे डाई. Okay, not bi, we call it as a di. Okay, when the names of the ligands include a numerical prefix, अगर उसमें न्यूमेरिकल प्रीफिक्स हो गया, अभी देखो PPH3 इसमें क्या है, ये भी 3 है और ये वो PPH3 कितने 2 है, तो that time what we will use is 2 for bis, 3 for kiss, and 4 for tetra. Okay, bis, tris, and tetra kiss are used for the ligand in which there are more numbers. Okay, so यहाँ पे देखो इस मॉलिक्यूल का नाम क्या हो जाएगा, डाइक्लोरिडो. क्लोरीन कितने हैं 2 है, सो इसलिए मैं यहाँ पे उसको क्या कहूंगी डाइक्लोरिडो बिस. बिस क्यों, क्योंकि ये क्या है PPH3 2 है, सो बिस ट्राइफिनिल फॉस्फिन, बाद में निकेल लिखो और निकेल की ऑक्सीडेशन स्टेट डालो सेकेंड. ओके, so oxidation state of metal in cation, anion or neutral coordination is indicated by a Roman numerical value. अभी हम लोगों ने लिखा था second, right? इस तरह से मैंने second लिखा था. If the complex ion is a cation, the metal is named same. अगर cation है हमारा complex, then जो भी हमारा metal का नाम होगा वो हम लिखेंगे. For example, copper CO in a complex cation is called as cobalt. That is not copper, sorry, it is cobalt. Okay. And platinum is called as a platinum. But if the complex is anion, the name of the metal ends with ATE. And if molecule is neutral, our complex is neutral, it is named similar to the cation. So for cation and for neutral, naming of metal is same. Naming for metal is same. Okay, metal का मैं बोल रही हूँ, पूरा complex का नहीं. Okay, I am telling you about the metal only, not overall complex. For complex, it will be what? Same. मेटल के लिए न्यूट्रल. ओके, फॉर न्यूट्रल एंड फॉर कटायन इट विल बी सेम, कुछ नहीं बदल होगा. अनायन के लिए हम लोग क्या करेंगे, चेंज, लास्ट में AT लगा देंगे मेटल के. ठीक है, तो यहाँ पे देखो मैंने कुछ एग्जांपल लिए हैं. यहाँ पे है हमारा सेंट्रल मेटल एटम निकेल, 2 क्लोरीन है और 3 फॉस्फिन है. ठीक है, मैंने जस्ट अभी आपको एक्सप्लेन किया कि हम इसको कैसे लिखोगे, डाइक्लोरिडो. ठीक है, हमारा क्लोरीन जो है, क्यों मैंने क्लोरीन लिखा, क्योंकि अल्फाबेटिकली हमको ऑर्डर करना था, अल्फाबेटिकल ऑर्डर से लिखना था, तो पहले C आता है, बराबर है, सो इसलिए क्लोरिडो. ओके, और वो कितने हैं 2 है, इसलिए डाई. और बाद में ट्राइफिनिल फॉस्फिन कितने हैं 2 है, इसलिए मैंने यहाँ पे लिखे 20 ट्राइफिनिल फॉस्फिन. देन व्हाट इज अवर नेक्स्ट, वी हैव टू राइट डाउन द कटायन, दैट इज निकेल, और उसका ऑक्सीडेशन स्टेट आप लोग निकाल सकते हो, दैट इज 2. हाउ यू कैन कैलकुलेट द ऑक्सीडेशन स्टेट, या डू यू नो दिस? How to calculate the oxidation state of a given central metal atom? You know, right? Or do you need the explanation for that? Okay, so now let's start with the next problem. That is what? IUPAC name of chromium, NH3 thrice, H2O thrice and Cl. देखो यहाँ पे बहुत सारे ligands present है. ठीक है, तो ये ligand क्या है, बाहर है, और ये 2 ligands क्या है, अंदर है. ठीक है, तो जो बाहर होगा उसको हम लोग लिखेंगे मेटल के बाद. ठीक है, जो अंदर होंगे तो उससे हम लोग पहले शुरुआत करेंगे, और उनसे शुरुआत करते वक्त हमको क्या ध्यान में रखना है, वी शुड स्टार्ट फ्रॉम द अल्फाबेटिकल ऑर्डर. सो दिस इज एक्वा एंड दिस इज अमाइन. ओके, सो विच इज more accurate according to alphabetical order? Amine is more accurate. So these are what? 3. So triamine, and these are also 3. So these are triaqua. Then this is positive cation, chromium. So that's why we have directly written chromium second chloride. How I get to know that this is a positive cation, positive complex? Because outer in the outer space there is a chlorine present, and chlorine is a negative ligand. So that's why the complex will have the positive charge on it, and that is what? Chromium 3 chloride. Next, AgNH3 and AgCN2. So these are 2 complexes present here. Okay, so AgNH3 twice, so I will write diamine silver 1, and for cyanide dicyanide argentate 1. So cyanide is what? Negative ligand. Silver amine is what? Neutral ligand. That's why we haven't changed the name of silver. Okay, Ag का नाम हम लोगों ने, we haven't changed the name of Ag, but here for negative complex I have done argentate. Okay, I have added ATE here. Everyone, is that clear? Right? Next, tell me the IUPAC name for sodium 3, this molecule, and this molecule. According to IUPAC nomenclature, sodium nitroprusside is named as. So I will give you just 1 to 2 seconds and you have to answer me the IUPAC names of these molecules. Yeah. What will be that? IUPAC name of Na3CONO2 6. Option A, B, C, D. Sodium cobalt nitrate, sodium hexanitrocobaltate, sodium hexanitrocobalt, sodium hexanitrocobaltate. B. Okay. B. Okay, let's see. I don't know the answer. You have to tell me the answer. Nitrito means what? Which ligand is that? Nitrito ligand. Okay, nice attempt of giving the answers here, but let's try to solve this. Okay, so sodium is what? Positive ligand here, and our complex will get negative charge, right? Na plus. So our coordination entity will have negative charge, right? So here what is happening is we have to name the molecule. So sodium is common. Okay, so sodium is common in everyone. Next is cobalt. So since it is having a negative charge, we should have a cobaltate. So यहाँ पे तो नहीं है, यहाँ पे है, और कहाँ पे है हमारा, यहाँ पे है. ठीक है, so this is also not happening. So next is this molecule, sorry, this ligand is known as a nitro. This is what? Nitro, not nitrito. Nitrito नहीं है ये. Nitrito कौन सा होता है? ONO. ONO is nitrito. Okay, guys, this is nitro. So that's why what is the correct answer? Sodium hexanitrocobaltate. So D is our correct answer. Okay, nitrito is this ligand. Okay, B is not the correct option. D is the correct option. Next, IUPAC name of K2NiCN4 is. अगेन यहाँ पे पोटेशियम पॉजिटिव है, एंटिटी पे हमारा कोऑर्डिनेशन एंटिटी पे हमारा आ रहा है निगेटिव चार्ज. सी. एक एक ऑप्शन कट करते जाओ और आंसर बताओ मुझे क्या आएगा. Okay, very good. Answer A is correct answer. Okay, here the name of the complex is what? Potassium tetracyanonickelate 2. Next, according to IUPAC nomenclature, sodium nitroprusside is named as. Yes. Do you know the structure of sodium nitroprusside? Okay, I will just give you the structure. Okay, Na2 Fe CN5 NO. Okay, so this is sodium nitroprusside. Tell me the name of it. Okay, here NO is what? Neutral ligand. And that's why ion will get 3 oxidation state. I will just explaining you this. Okay, इतना मैंने आपको बताया. अभी मुझे बताओ क्या होगा आंसर हमारा. will be our answer here. Yes, 1, 2, 3. Okay, 1, 2, 3. The answer. Okay. Okay. So here, according to the IUPAC nomenclature, sodium nitroprusside is named as sodium pentacyano-nitrosyl ferrate 3. Sodium pentacyano-nitrosyl ferrate 3. Okay. So that will be our answer. Okay. That will be our answer. Very good. Those who have tried, very good. Okay. Now let's go to the next topic. That is Werner's coordination theory. So Werner coordination theory was very helpful in order to explain the bonding present for a given coordination compounds. So the postulates of Werner theory was, as we have seen, that our coordination compounds metal and there are certain ligands surrounding to it. Okay, so he was trying to decode the structure of the coordination compounds and get to know what are these ligands will do, what is the nature of metal present in these coordination compounds, and he postulated some topics. He postulated some things from that. So metal shows two different kinds of valencies in a given coordination compound. One is a primary valency and another one is a secondary valency. Okay, so the ions groups which are bounded to the secondary linkage to the metal have characteristic spatial arrangement. Which are in the secondary linkage, they have a spatial arrangement and corresponding to different coordination number of a given coordination compound. Jitne coordination, whatever will be the coordination number of a given coordination compound, that will be showing the secondary valency and they will have a special arrangement around that given metal, central metal atom. The most common geometrical shapes in the coordination compounds are octahedral, square planar, and tetrahedral that we know. Okay. Primary valencies. What are the primary valencies? They are normally ionizable. What is the meaning of this? So if there are certain valencies which are, see, this is our metal atom, ligands are attached to it. So there are two types of ligands. Certain ligands are what? Present here at the start and certain ligands are present at the end. Okay, so these ligands are what? Primary. Sorry, these are what? Primary valencies. This is what? Primary valency. This is what? Primary valency. Primary valency. And those which are inside, these are what? Secondary valencies. These are what? Secondary valencies. ठीक है, समझ में आ रहा है सबको? These are what? Secondary valencies. Okay. These are what? Secondary valencies present here. Okay. And these are what? Primary valencies present here. ठीक है, so ये जो secondary valencies है, whatever the secondary valencies present in the given coordination complexes, they give the spatial arrangement, they give the structure to a given complex. Tetrahedral, octahedral, square planar, depending upon the number of ligands present. If there are 4, it can be tetrahedral or square planar. If there are 6 ligands, it will be octahedral. Right? So these primary valency I was talking about, they are ionizable. So these are ionizable. What is the meaning of that? Since they are outside of the coordination brackets, they can be ionizable. Means if we add a counter reagent into that, suppose these are Cl. Okay, ये यहाँ पे Cl है और यहाँ पे suppose यहाँ पे क्या है, काउंटर पॉजिटिव चार्ज होगा. ठीक है, यहाँ पे हमेशा निगेटिव होता है लास्ट में और आगे कौन से होते हैं? हमेशा पॉजिटिव लिगेंड्स होते हैं. तो सपोज यहाँ पे Cl है. ठीक है, तो अगर इसका मैंने काउंटर रिएजेंट ऐड किया इस कंपाउंड में AgNO3, so what will happen? AgNO3 will combine with this Cl present in this complex and it will form AgCl. And it is going to form what? AgCl. तो ये क्या हो जाएगा? ये आयोनाइजेबल हो गया. ठीक है, AgNO3 के साथ रिएक्ट हो गया. That is, it is a ionizable. It is equal to positive charge on central metal atom. These valencies are satisfied by negatively charged ions. Primary valencies जो है मोस्टली वो किससे सॉल्व होते हैं, किससे satisfy होते हैं? They are satisfied by negatively charged ions and they are also satisfied by the positively charged ions. Okay, यहाँ पे positive भी है, not only negative. Next, secondary valencies. So these valencies are non-ionizable. If suppose metal, ये जो हमारा component है, हमारा coordination compound है, यहाँ पे अगर क्लोरीन प्रेजेंट है suppose, तो यहाँ पे जो क्लोरीन प्रेजेंट है ना, वो आयोनाइजेबल नहीं होगा. AgNO3 तुम कितना भी डालो, it won't get ionized. Okay, whatever amount of AgNO3 you will add, if the chlorine is present inside the coordination bracket, then it will not ionizable because it is what? Secondary valence. secondary valency equals to the number of ligands coordinated to the metal. It is also known as the coordination number of the metal, and it is satisfied most of the time by neutral, negative charge, and sometimes positively charged ligands. Is that clear to everyone? So now let's solve one simple problem. When 1 mole of CrCl3 6H2 is treated with excess of AgNO3, 3 moles of AgCls are obtained. The formula of the complex will be. So now, right now I have told you which get reacted if they are present outside of the coordination bracket. Okay, so here 3 AgCl are forming when you are adding AgNO3. So 3 Cl are present outside. So chromium may be containing, so here chromium containing 6H2O, and that's why these 3 Cl are what? Primary valencies. These 6H2O are the secondary valencies, and you will get the 3 AgCl. So what will be the formula for given complex? It will be this one, right? Any doubt? Any doubt? You are getting this, right? Everyone? 16 participants are there. Yes? Are you getting this, right? Okay, okay. Thank you for responding. Next. Okay, 3 molecules. So that's why 3 are present outside of the coordination sphere, and that's why we will call them as a, that's why they are giving us the 3 AgCl molecule, and that they are, since they are primary valences, that's why. Now, which does not give a precipitate with AgNO3 solution? So you have to give me the answer of this. आपको मैंने बोला ये आपको समझ में आ गया? You have understood this, right? So tell me the answer for this. Which does not give a precipitate with AgNO3 solution? Yes, A, B, C, D. Which will not give a precipitate with AgNO3 solution? Yes, if primary valency is not present outside of coordination sphere, okay, then there will be no reaction with AgNO3. So यहाँ पे 3Cl3 है, यहाँ पे 1 Cl है, यहाँ पे 2 Cl है. So these are not our correct answer, because they will undergo into ionization, okay, and they will give AgCl. So here the Cl3 is inside the bracket, that's why it will not undergo into ionization, right? Next, let's start with the isomerism. So isomers are of 2 types. One is a structural isomerism and another one is a stereoisomerism. So our coordination compounds show both the isomerisms. Okay, both the isomers are obtained, structural as well as stereoisomers. So you know stereoisomers are of 2 types, geometrical as well as optical. And most of the time the square planar complexes show these stereoisomers. So stereoisomers, when we talk about geometrical stereoisomers, they are of 2 types, cis and trans. They are what? Cis and trans. Okay, and 2 more isomers are there, which is known as spatial and meridial. So cis means what? Same groups are present to the same side, it is known as cis, and when same groups are present to the opposite side, so it is known as trans. Spatial means what? When they are having this 1, 2, 3, same ligands are present at 1, 2, 3, it is known as spatial. When ligands are present at 1, 2, 3, 4, 5, 6. So this is known as meridian. See, this is and this is. These are the ligands present in this position. It is known as meridial isomer. When the same ligands are present in such a position, it is known as spatial isomers. Next, structural isomerism, linkage isomers, coordination isomers, ionization isomers, and solvent isomers. Okay, so what is the meaning of linkage isomer? So linkage means what? A given ligand is attached to a central metal atom with 2 or 2 different atoms. ठीक है, तो NO2 हमारा एक ligand है. इसका जो लिंकिंग है वो 2 प्रकार से हो सकता है. ONO जैसे भी हो सकता है और NO2 जैसे भी हो सकता है सेंट्रल मेटल एटम के लिए. So their linking is what? Different, and that's why it is going to form 2 isomers. Okay, that's why it is going to form the isomerism, and these are the 2 isomers. Okay, nitrate ion bound through either oxygen or nitrogen, and they are giving us a linkage isomerism. नेक्स्ट इज कोऑर्डिनेशन आइसोमेरिज्म. यहाँ पे क्या हो रहा है? 2 कोऑर्डिनेशन स्फीयर हमको दिख रहे हैं. यहाँ पे कोबाल्ट है, यहाँ पे क्रोमियम है, यहाँ पे NH3 है और यहाँ पे CN6 है. यहाँ मैंने क्या किया कि क्रोमियम को मैंने चेंज किया और इस यहाँ पे डाल दिया, और कोबाल्ट को मैंने चेंज किया और यहाँ पे डाल दिया. Okay, so you are getting interchange of ligands between cationic and anionic entities when you observe. Then those 2 molecules or those two complexes will be the coordination isomers of each other. These are coordination isomers of each other. These two are what? Linkage isomers of each other. Next, ionization isomerism. So what is the meaning of ionization isomerism? So here you can see CONH3 5SO4 Br. When you will add a reagent into this, it will give us Br as outside means primary valency here is Br. बट यहाँ पे कौन सी प्राइमरी वैलेंसी SO4 है. सो उस प्रकार से जब हम लोग इसमें डालेंगे कंपाउंड तो हमको आयोनाइज क्या होगा, पहले Br होगा पहले कॉम्प्लेक्स में और दूसरे कॉम्प्लेक्स में हमको मिलेगा SO4, राइट. सो दे गिव डिफरेंट आयन इन सॉल्यूशन सिंस दे आर हैविंग द डिफरेंट प्राइमरी वैलेंसी. तो यहाँ पे SO4 है अंदर, इसलिए ये आयोनाइज नहीं होगा, और यहाँ पे Br है अंदर, ये आयोनाइज नहीं होगा. Those which are outside of the coordination sphere, they are undergo ionization, and that's why these two complexes are what? Ionization isomers of each other, because in solution they give different ions. Next, solvate isomerism. Solvate isomerism means what? They are aqua complexes. Okay, here this is one complex, this is another complex. You can see the rearrangement of ligands are different, and that's why these two are what? Solvate isomers of each other. This is very, very important. Okay, one question is definitely going to ask from this PPT. Okay, next, so very important points I have summarized here. You can have a look on this. So tetrahedral complexes will not show a geometrical isomerism. Very, very important. Only and only square planar complexes of the type Ma2B2, Ma2BC, MABCD are going to show geometrical isomer. ये क्या है? A2B2, A2BC और ABCD. These are the ligands. Okay. MX4 type of coordination complexes are going to show the geometrical isomerism. तो यहाँ पे दो सेम होंगे, या फिर दो अलग और दो सेम होंगे, या फिर चारों अलग ligands होंगे. They are going to show the geometrical isomerism. Next, square plane complexes containing unsymmetrical bidentate ligand. If our bidentate ligand is unsymmetrical, they are also going to show the geometrical isomerism. They are also going to show the geometrical isomerism. Okay, please remember this. This is again a very important point. Octahedral complexes of Ma3B3, Ma2A2, MAB3 shows geometrical isomers. So this is what bidentate ligand. See, bidentate ligand. Okay, octahedral complexes with this type of will show optical isomerism. Okay, very important. You should remember this, right? Next, जो हमारे linkage isomers है, ठीक है, वो कौन कौन से? The coordination compounds containing ambidentate ligand. Ambidentate ligand means what? They are having two or more. They are having one or two donating linking atom in that. Okay, but the linking will be different. NO2 इसे नाइट्रोजन से लिंक होगा और इसमें ही ऑक्सीजन भी है, वो ऑक्सीजन से लिंक होगा. ठीक है, सो दीज टू आर व्हाट? दे आर लिंकिंग आइसोमर, दे शो लिंकेज आइसोमेरिज्म. दे आर लिंकेज isomers of each other obtained in the form of yellow and red color. तो इन दोनों के कलर कौन से? येलो और रेड. कोऑर्डिनेशन कंपाउंड्स कंटेनिंग टू कोऑर्डिनेशन एंटिटीज शो कोऑर्डिनेशन स्पेरी. देखो मैंने आपको यहाँ पे एग्जांपल दे दिए हैं. ये भी आयोनाइजेशन दिखाता है और ये सॉल्वेंट दिखाता है. ठीक है, नेक्स्ट, tell me the answer. The type of isomerism shown by this complex will be. तो isomerism पे अभी मैंने दो चार प्रॉब्लम्स लिए हैं. Let's solve them. Okay, the type of isomerism shown by this complex will be ionization, coordination, geometrical isomerism, linkage. So this is what MA2, right? AA2, right? Okay, so what will be the C? Ma2B2 exhibit geometrical isomerism since En is what? Bidentate ligand. It can show, okay, cis and trans isomers. That's why they will show the geometrical isomerism. Okay, they will show the geometrical isomerism. You can see this. हम लोगों ने अभी यहाँ पे लिखा था A2 कौन सा दिखाता है? Geometrical isomerism दिखाता है, optical isomerism नहीं दिखाता है. ठीक है, only cis shows the optical isomerism. लेकिन यहाँ पे optical isomerism का ऑप्शन ही नहीं था. So what is the correct answer? Geometrical isomers, right? Next, which one of the following complex ions has geometrical isomers? COEN3 plus, NiNH3 plus, CrNH3 ABCD. Which is the correct answer here? Valina, okay, C. Yeah, Valina, very good. C was the correct answer. Very good. Next, which of the following complex ion has geometrical? Next question मैंने पूछा है यहाँ, इसमें से कौन सा होगा बताओ geometrical isomer हमारा? Okay, Valina, let's see. So here, when you see the first one, it is optical only. Okay, optical isomer. Second one is no geometrical isomer. Third one is cis and trans, that is geometrical isomer. And fourth one is no geometrical isomer. So, Valina, very good. The answer option C is correct. Next, indicate the complex ion which shows geometrical isomerism. Again, the same question. Which will be showing the geometrical isomerism. A, B, C, D. Very simple. Geometrical isomerism means what? Which will show cis and trans isomers. Right now it is octahedral complex. For octahedral complex, which will show the cis and trans? Tarun? C. Okay. Chaitanya? A. Okay. Okay. A. Okay. 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 Very good. Very good. Thank you for responding. So here answer A is correct answer because it is MA4B2. Okay, it can show cis isomer as well as trans isomer. How it is going to show the cis isomer? This is our metal atom. Okay, cis means what? Here B will be present. B and B here. A are present here. Okay, and metal atom having A is here, right? And B is here. This is what? Trans. Okay, sorry for my writing. Fast I am writing, na? That's why. Cis and trans. Okay, very good. Right. Next. Which of the following compounds show optical isomerism? Now I have asked about optical isomerism. See, most of the examples are asked in the previous year questions. Okay. Which of the following compounds show optical isomerism? 1, 2, 3, 4. Okay, let's go. So which is this option? Option B. Option B is the correct answer. It is going to show us the optical isomerism. Optical isomers means what? The compound should be, the isomer should be non-superimposable mirror images of each other. Okay. Next, which of the following complex will show geometrical as well as optical isomer? Now this is a combining the concept problem. Optical भी है और geometrical भी है. कौन सा है बताओ? Which of the following complex will show geometrical as well as optical isomerism? Simple. Okay, try to do that. Okay, answer will be what? Platinum, En2Cl2. That is option C is the correct answer here. It is going to show cis and trans isomer also, but the cis isomer will be optically active. Okay. Next, which of the following compounds exhibit linkage isomerism? Yeah. Last problem. लिंकेज के लिए हम लोगों को क्या देखना है? हमारा जो लिगेंड है उसमें ऐसा लिगेंड होना चाहिए. The ligand should be in such a way that it is having two linking or donating species. Yeah. Yes, yes, yes. More replies. What is the correct answer? A, B, C, D. So linkage के लिए we have seen that NO2 group shows the linkage isomerism. So that's why option C will be correct. Those who have given the different replies, please read about linkage isomerism. I have explained. Okay, in that I have shown that NO2 is the ligand which will show the linkage isomerism. Next will be T, that is valence bond theory. So in order to determine the bonding present in this coordination compound, so many theories has been put forward. So let's talk about the first theory, that is valence bond theory. You must be knowing that what is the valence bond theory. So here metal ion is the central metal ion. A number of empty orbital it contains. So central metal atom के पास क्या है? They have some empty orbitals into them. In order to accommodate the electrons, which are donated by the ligands. Metal atom have certain orbitals. Okay, empty orbitals. They should have the empty orbitals in that. Since most of the metal atoms are from D block, so that's why I have writing the D means 10 5 dabbas of this. Okay, means there are maximum 10 electrons can accommodate. Okay, so a central metal atom should have the empty D orbitals in it, and the atomic orbitals then hybridized. Okay, since metal के अंदर यहाँ पे देखो 3D है, then 4s है, then उसके बाद 4p है, so D, S, P, there are different orbitals present, and you know that all these orbitals have different energies, right? But we need to form a complex. So in order to form the complex, the orbitals should have the same energies. So in order to have them same energy, we are hybridizing them. Hybridizing means what? Mixing and recasting of the orbitals. We are taking s orbital, p orbital, d orbital, we are mixing them. Since they are having the different energies, when we mix them, we are making the new orbitals, and those orbitals will have the same energies. Those orbitals will have the same energies, and such orbitals are known as hybridized orbital. Okay, such orbitals are known as the hybridized orbitals. So these hybrid orbitals with definite directional properties, these hybrid orbitals now going to overlap with the ligand's orbital. So before approaching the ligand, all these things are going on inside of the metal atom, and as soon as the hybrid orbitals are formed, the ligand will give their electron, and in those hybrid orbitals of metal atom, those electrons are going to accommodate. Okay, so depending upon the coordination number 4, the type of hybridization which will occur is sp3, and the complex will be tetrahedral. Since there are 4 coordination compound, if such type of hybridization has been takes place, it will be square planar. It will be next trigonal bipyramidal. If 6, octahedral, sp3d2. If inner d orbitals are used, it will be again octahedral, but its coordination, hybridization will be d2sp3. These are outer d. ठीक है, outer d मतलब क्या? अभी देखो, suppose करो हमारा complex है, we will see the examples of that. Okay, I have taken the examples. Okay, so the d orbitals involved in the hybridization may be either inner orbital d orbital or they are outer nd orbitals. So the complexes formed in those ways are referred as low spin and high spin. Okay, उन्होंने directly बता दिया कि जो अंदर के होंगे उनको हम लोग low spin बोलेंगे, और जो बाहर के d orbitals अगर हम लोगों ने यूज किए तो उस कॉम्प्लेक्स को हम लोग क्या बोलेंगे? Then those complex will be known as a high spin complexes, right? If the complex contains unpaired electron, okay, after filling these d orbitals, which are hybrid d orbitals, if it is contained the unpaired electron, then the complex will be paramagnetic in nature, and if it doesn't contain the unpaired electron, it will be diamagnetic in nature. Next. Okay, so I have summarized all those things here again. Now let's see the problem. So this complex, and this complex are what? D2sp3 hybridized, and they are inner orbital complex because they are using the inner d shell. Okay, these 3 complexes are what? sp3d2 hybridized because they are using outer orbital complex. This is very, very important. Okay, nickel complexes. So nickel complexes are what? sp3, and d2sp3. So this is sp3 hybridized. Please note these 3 complexes. They are very, very important. Example आने वाला है इस पे से, ठीक है, प्रॉब्लम आने वाला है. So this is sp3, this is d2sp2. That is what? This is tetrahedral, and this is square planar in nature. Okay, and what about their magnetic nature? So this is diamagnetic, this is paramagnetic, and this is again diamagnetic. Very, very important 2 points. Okay, you should mark them. Next. Which of the following complex is an outer orbital complex? So what is the meaning of outer orbital complex? They should be having the outer d orbitals in it. So try करो, उनका atomic number दिया हुआ है, उससे आप लोग try करो इस तरह से, ठीक है, find out करो. 3d 4s 4p पहला जो complex है that is inner orbital complex, दूसरा भी क्या है? Inner orbital complex, third भी inner orbital complex है, last वाला जो है that is the outer orbital complex. That's why our answer will be D. Next, the number of unpaired electrons in the complex ion will be COF6 3- हम लोगों को दिया हुआ है, उसका एटॉमिक नंबर दिया हुआ है, उसका आप लोग निकालो. ठीक है, आपने अगर देखा कोबाल्ट के पास कितने हैं इलेक्ट्रॉन्स है, यहाँ पे 6 इलेक्ट्रॉन्स है. अनपेड इलेक्ट्रॉन कितने? 4 अनपेड इलेक्ट्रॉन होने के कारण उसकी जो हो सकती है, ठीक है, 4 होगा. आंसर विल बी 4. नेक्स्ट, CFT, that is crystal field theory. So this theory actually tells us that the metal and ligand, they act as a point charges. ओके, वैलेंस बॉन्ड थ्योरी में हम लोगों ने क्या देखा कि ऑर्बिटल्स में क्या आ रहे हैं, इलेक्ट्रॉन्स आ रहे हैं और उस तरह से वहां पे बॉन्डिंग फॉर्म हो रही है। लेकिन क्रिस्टल फील्ड थ्योरी में क्या डिफाइन किया है, दिस इज अबाउट वी आर going to talk about that our ligands are like a point charges. If they are anions, point charges, in case of anions, they are negatively charged. If in case of neutral, they will be the dipoles. Okay, so there are 5d orbitals present, dxy, dyz, dzx, dx square, y square, and dz square. They are oriented in between the axis. Some are in between the axis and some are along the axis. Okay, oriented along the axis, and due to that, they will have the different kind of energies. So series in which ligands are arranged in order of increasing magnitude of crystal field splitting energy, that is CFAC. Very, very important, CFAC. So this is a spectrochemical series. You should remember, if our complex contains CO in it, then it will have the highest CFAC. If our complex contain iodine in it, okay, it will have less CFAC. Okay, in case of octahedral complexes, energy of EG set of orbitals is greater than T2G set. तो octahedral के लिए यहाँ पे क्या होता है, EG above होता है और T2G नीचे होता है. T2G में 3 ऑर्बिटल्स होते हैं, EG में 2 ऑर्बिटल्स होते हैं. This is for octahedral complex, right? Okay, so here the difference is what? For T2G it is 3/5 minus and here plus 2/5 energy. ठीक है, डेल्टा नॉट हम लोग क्रिस्टल फील्ड स्प्लिटिंग एनर्जी ऑक्टाहेड्रल के लिए कैसे दिखाते हैं, डेल्टा 0. ओके, राइट? For strong field ligand and weak field ligand, what is the case? So for delta 0 is less than P for weak field ligand, and delta 0 is greater for what? Strong field ligand. That is, if ligand is weak field, then it shows high spin complex. What is the meaning of high spin complex? Is that weak. देखो यहाँ पे हम लोगों ने इस तरह से ये ड्रॉ किया है 1, 2 and 3, and this is 1 and 2. ठीक है, 2 ऑर्बिटल्स है T2G and this is EG. ठीक है, तो यहाँ पे क्या होगा, अगर पेयरिंग एनर्जी, पेयरिंग मतलब क्या, P जो है हमारा, दिस इज शोइंग द पेयरिंग एनर्जी. पेयरिंग मतलब क्या, शुरुआत में इलेक्ट्रॉन एक ही था, अगर मैंने दूसरा इलेक्ट्रॉन यहाँ पे डाला तो व्हाट विल हैपन, देयर विल बी द एनर्जी व्हिच आई हैव टू गिव इन ऑर्डर टू पेयर अप दिस इलेक्ट्रॉन विद दिस इलेक्ट्रॉन, फर्स्ट इलेक्ट्रॉन. Okay, so if that pairing energy is less, then and then only the pairing will take place. And then only pairing is going to take place. If that energy is higher, then what will happen? The pairing will not take place. But with respect to what? With respect to what it will be less, and with respect to what it will be more. So with respect to this gap, that is known as delta naught. That is what CFAC, crystal field splitting energy. If crystal field splitting energy is more than pairing energy, then and then only pairing is going to take place. So it is happening with the pentam. Very important concept. Okay. Wait. See, if delta naught is greater than P, since this gap is greater, what will happen is electrons are going to pair up because gap is more. The energy required to go to electron to higher orbital is more than energy required to pairing off. So what will be the favored by a given complex? So favor किसको होगा कि pairing हो जाएगी. Pairing हो जाएगी, नीचे वाले orbitals fill हो जाएंगे. That's why it will be known as a low spin complex. It will be known as a low spin complex. Okay. If delta naught, something has been happened with my pen tab. Okay. If delta naught is less than P, what will happen? The complex will be weak field, means pairing जो delta naught जो हमारा difference है, gap है, that is less. So what will happen? The next incoming electron is going to be fill into the upper orbitals. Okay, that is EG orbital में electron जाएगा, EG orbital में electron जाएगा, and that's why the complex will be high spin complex. So first of all मैंने low spin का आपको explain किया. Okay, low spin when delta naught is greater than P, pairing will take place and our complex will be low spin. When delta naught is less than P, then pairing will not take place. The incoming electron will go to the upper orbitals and the complex will be high spin and this will be low spin. Okay, tetrahedral complex energy of T2G orbital. Reverse of this will happen for T2G. Reverse of this will happen for tetrahedral. EG orbitals are lesser in energy as compared to the T2G orbital. Okay, pairing of electron is not possible in tetrahedral complex, so they all are what? High spin. Very, very important points. Okay, all are high spin. Okay, so I have shown you here the energies of d orbitals of octahedral as well as tetrahedral spectrochemical series. Again, weak field, strong field. Okay, and the relation between tetrahedral and octahedral is in this way. Okay, delta T 4/9 delta 0, right? Please remember this. Next, these are some problems. Which one of the following ion exhibit DD transition and it is paramagnetic as well. तो आप सब ABCD को कंसिडर करो, ये रीड करो, नंबर ऑफ इलेक्ट्रॉन फाइंड आउट करो, आपको मिल जाएगा आंसर. ठीक है. Which one of the following ions exhibit DD transition and paramagnetism as well? ठीक है. Next, which of the following pairs of DD orbitals will have electron density along the axis? मैंने बोला था कि the d orbitals consist of 5 d orbitals. Some are along the axis and some are in between the axis. So which are along the axis? So these two are along the axis. So option C is the correct answer. Okay, these are along the axis and these are in between the axis. It is already written. You can read this. That the geometry and magnetic behavior of the complex are NiCO4. What is the geometry? I have told you. क्वेश्चन आएगा NiCO4. NiCO4 कहाँ पे था मेरा मोलिक्यूल? NiCO4 कहाँ है? NiCO4 क्या है? इसका ज्योमेट्री sp3 और इसका मैग्नेटिज्म क्या है? डायमैग्नेटिक, राइट? सो इट इज व्हाट? sp3 and diamagnetic. sp3 means what? Tetrahedral geometry and it is diamagnetic. It is tetrahedral as well as diamagnetic. If descriptive explanation is given, you can read this. Okay, very, very important. Next, crystal field stabilization energy for high spin octahedral complexes. And second problem is calculate the crystal field stabilization energy, which will have the zero crystal field stabilization energy. इनमें से किसकी जीरो है? ऑप्शन दिए हुए हैं. और किसकी स्टेबलाइजेशन फॉर हाई स्पिन कॉम्प्लेक्स विल बी? D4 हाई स्पिन कॉम्प्लेक्स के लिए क्या आएगा? क्रिस्टल फिल्ड स्प्लिटिंग एनर्जी. सो लेट्स सी दैट. So first problem in high spin complex for D4, what will happen? It is a high spin, right? So first of all नीचे के फिल हो जाएंगे. हाई स्पिन है इसलिए नेक्स्ट इलेक्ट्रॉन फोर्थ में चला जाएगा. क्रिस्टल फिल्ड स्प्लिटिंग एनर्जी जब हम लोग कैलकुलेट करते हैं तब हम लोग कैसे कैलकुलेट करते हैं? The 3 electron present here multiply by electrons present in T2G, okay, minus electron present in EG. Okay, कैलकुलेट करो, आपको आंसर आ जाएगा. देखो, crystal field stabilization energy 3 electrons present into 0.4 plus, sorry, we have to add it. Okay, we have to add it with the 1 electron present here. You will get the answer like this way. Simple addition and multiplication. सबको समझ में आया? इसमें the number of electron present in the below orbital, okay, plus number of electron present in the above orbital. So here I will give the minus sign to this. Okay, this is minus. And in that way, calculate that, you will get this answer. Next, 0 किसकी है? So 0 is for FeH2O6 3+. Next, color in the coordination compound. So due to the DD transition, our coordination compound shows some color. So first complex is violet in color. This complex is blue in color. Then there are some more. This example is pale blue. This is blue or purple and this is violet. Very, very important. Try to remember these complexes and their numbers. Okay. Why that is happening? Color is happening due to the jump of electron from lower T2G orbital to the higher EG orbital. And when that electron comes to the ground state again, it emits the light. Okay. And that's why they are colorful in nature. Okay. अगर लिगैंड नहीं होंगे तो वहां पे कलर नहीं होगा. ठीक है. अभी रूबी जो है, रूबी is Al2O3 containing chromium plus 3 ions. And you know the color of ruby, right? It is what color of ruby? What is the color of ruby? Next, metal carbonyls. So metal carbonyls are the compounds which contain CO. They are homoleptic, only contain CO ligand. So this is metal carbonyl. In metal carbonyl, what is happening? Sigma bond is also present as well as pi bonding is also present. And such a type of pi bonding is known as back bonding. Okay, metal to carbon sigma bond form होता है. Metal to carbon sigma bond form होता है. As well as यहाँ पे जो orbitals present है कार्बन के, वहां से क्या होता है? pi electron donate होते हैं metal को, and that's why this is a pi bonding and this is a sigma bonding. And such type of pi bonding is known as back pi bonding. Okay. Okay. So there are certain examples I have shown here. Okay. But FeCO5, these are trigonal bipyramidal. This is octahedral. This is made up of 2 square pyramidal units, and there is a presence of MNMN bond. Very, very important things. Just write down all these things. Okay. Hardness of water is estimated by using this. Gold can be separated by using this. Wilkinson reagent is this one, which is used in hydrogenation of alkene, and that is a coordination compound. In photography, hypo solution dissolves AgBr. Okay, this is the solution. EDTA is used in the treatment of lead poisoning. Okay, EDTA is used in the lead poisoning. Cisplatin is used for the inhibiting the growth of tumors. क्लोरोफिल में मैग्नीशियम प्रेजेंट है, हेमोग्लोबिन में आयन प्रेजेंट है, विटामिन B12 में कोबाल्ट प्रेजेंट है. वेरी वेरी इंपॉर्टेंट. Okay. Excess of copper and iron are removed by chelating ligands like D-penicillamine and desferoxim B. Very very important slide. Okay. Make the notes of these and try to remember these. Coordination compounds are used in medicinal chemistry, electroplating and textile dyeing. Okay, there are certain examples. Try to solve them by yourself. If you have any doubt, you can ask me. And that's it for today's lecture. 5 minutes extra हो गए. Okay. But that's it for today's lecture. ये last वाली जो problems है आप लोग solve करो. You have the following compound is not colored and answer are supplied to you. So no problem. Till if you have any doubt, you can ask. That's it for today's lecture. Okay. Let's meet tomorrow. Okay. Have a nice day. Bye-bye.